Okay. Good afternoon, everybody. I'm very happy to have you here. This is the webinar for the second open call of the project 6EXR. We will have today some slides related to the process, to the infrastructure, to the project, and the topics that we are covering from the second open call of 6EXR. And at the final stage, we will have also the possibility to answer some questions from the participants' side. So I will give the floor to our coordinator, so you can present the agenda, Josie, and also the project and the main objective of the open call as well. Please let me know when to change the slides.
Okay, thank you. So welcome everyone. My name is Jussi Haapula. I'm the project coordinator of 6GXR. So today's agenda is we're briefly going to introduce the agenda and the project itself, and then we'll go through the second open call processes. Afterwards, we go with the description of the four different research infrastructures we have in the project, and finally the topics of the topic open call 2 that we are especially interested in. Finally, we have a slot for Q&A. So next slide, please. Okay, so the 6GXR is a StreamC project. So we're on our second year now. It has basically a number of different work packages and objectives. So we are working on multiple different aspects. We are both a research infrastructure project and a use case project. So on one hand, we are developing things like networking and computing enablers. We are also developing run enablers and an energy measurement system for basically being able to monitor the entire telecommunication network. And then on the other hand, we have our use cases, which are focused on extended reality, so namely holographic communications and 3D digital twins. So with this open call 2, we are looking for projects that span out of the stream B thematices, and especially of our interest are reflective intelligent surfaces risks, deterministic communications, energy measurement, contributions, AI/machine learning for slicing. We're looking for solutions for load balancing, also for security and trust mechanisms, for increased capacity. And of course, since this is an open call, we have the other stream B thematices. So next slide, please. Okay, so the key dates are, so we opened up the call on March 22nd, and we will basically have the final submission deadline of May 22nd. I believe that there is actually the first draft proposal for the feasibility check deadline is incorrect in here. It should be 22nd of April. So after the final submission deadline of the 22nd of May, we will have basically a second feasibility check, after which basically we process the submitted proposals that pass the feasibility check to external expert reviewers, and the plan is to have a notification of the results for the granted 10 projects in this open call 2 on the June 30th, 2024. The plan is to start the experiments as soon as possible at the 2nd of September, so just passing the summer holiday periods in Europe. And then the plan is to conduct these experiments and finish them by the 2nd of March, which makes it 6 months. So next slide, please. So of course, as this is a part of the SNSJU initiative, so we are especially targeting SMEs, but we are not precluding anybody else either. So this is open call is open for SMEs, industries, research and scientific organizations, as well as academia. So essentially all organizations that are eligible for Horizon Europe funding can participate in these proposals. So the eligibility to be funded, first of all, you have to be a legal entity established in the EU member state or associated country. We only accept single party submissions. There must be absolutely no basically conflict of interest with 6GXR that makes all of the 6GXR partners ineligible for funding. The type of activity we cover is the personal cost, the travel cost, and as well as the indirect 25% overhead costs. So one of the important aspects here is that the proposals to be submitted, they need to follow the Stream B thematices of SNS joint undertaking. The proposals are also required to justify the linkage to Stream B thematices, and if the proposal is coming directly from a Stream B project or projects, it's required to ensure that the proposed work is not already covered by that or those said existing Stream B projects, but they are in fact novel, they go beyond the state of the art, or they do something else that is basically not included in the particular Stream B project grant. So if the proposal is based on a Stream B action, there needs to be a clear justification basically of it. So the proposal needs to be submitted in English language. Basically, there is a website tool for the submission that must be used to be eligible. The final deadline is the 22nd of May, 1700 Central European time, and all the feasibility check deadline is on the 22nd of April, so 1 month from the start of this open call at 1700 Central European time. All submission must also be GDPR compliant. So in general terms, all the approved projects in this open call 2 must be made available, so they can be basically for other experimentals for the rest of the 6GXR project duration. Namely, they need to be also available for the so open call 3 thematices, and also the 6GXR must be able to use it. A special part is that we have a number of subtopics in this, basically what we are generally interested in, and the other proposals, we are only going to accept maximum 3 proposals under any given subtopic, regardless of the evaluation results. So all proposals that pass the feasibility check will be sent for evaluation, and the evaluations will be done by external experts that have no conflict of interest with 6GXR, and they are the ones who basically provide the evaluation results, and basically based on that the projects are ranked. And even though regardless of the ranking under any given subtopic, a maximum 3 proposals are considered for funding. Next slide, please. So all in all, the expected project duration is 6 months. Well, the maximum funding per project is 60,000 euros. We will fund 10 projects, in total 600,000 euros. The payment will be a lump sum payment after the awarded project has been accepted by the project. So the final report, financial and technical, needs to be submitted within 15 days after the completion of the open call project. And the assessment and approval of the project will be done by the consortium. Of course, the mentor plays a big role in there. There exists an online tool for the submission process that you must use in the submission, and items worth mentioning is that there is a stage. So the feasibility check needs to be checked in when you are submitting the proposal for the first feasibility check with the deadline of 22nd of April. And then the final submission that has the deadline of 22nd of May basically needs to be clicked. So even if the feasibility check of a proposal has been carried out and it's the project is feasible, unless you check the final submission before the 22nd of May, the project is not considered for funding. So you must include this final submission in the fund in that part. The second thing of note is that you have to select from the downtown so that the proposer confirms that the submitted proposal and the described activities are novel and not covered by existing Stream B projects. And basically, if it's based on a Stream B action, it goes beyond or differentiates to the existing activities, and proper justification are provided. If you have any questions on it, please feel free to ask on our email opencalls@6gxr.eu. So we will evaluate, or the external experts will evaluate the projects on the following criteria. So clarity and methodology, ambition, and in ambition you also need to justify the proposal with relations to SJU Stream B thematics. Then there's impact, replicability, contribution to standardization, team capacity, value for money. SME participation is encouraged but not mandatory. Gender dimensioning awareness, and the maturity of the organization of the proposers to the specific fields. There will be maximum one awarded project per organization, so you are able to submit multiple proposals, but in case of acceptance, only one of them will be awarded, regardless of how well all of the proposals succeed. There are 2 external experts that evaluate each proposals. Afterwards, we will have a consensus meeting and make a final ranking and approval of the proposed projects by the Open Call Steering Committee. After the evaluation, there's legal and financial check. So we need to sign the third-party agreements, and basically the implementation will be done with guidance of the mentors. Next slide, please. And next, we'll go to the research infrastructures. So as I said, we have 4 research infrastructures, what we call so essentially we have 2 nodes in the project. We have a south node and a north node, and within those nodes, in both of them are 2 different research infrastructures. In the south node, there is Phibetonic in Madrid and 5G Barcelona in Barcelona, and in the north node there are 2. There is the 5GTN VTT test network, and then there's the 5GTN University of Oulu test network. So next slide, please. So I'll replace Antti Pavonen here, describing a bit about the North Node. So this is the University of Oulu campus 5G test network. So we are essentially a micro operator in a sense that we have our own SIM card base, and we have complete control of our network infrastructure. We have both a non-standalone and a standalone 5G connectivity available. We have 2 macro base stations and about 20 indoor base stations at the university campus for different amounts of testing. We also support 4G since we have the standalone as well, we have cellular IoT, 400 plus sensors at the campus, constantly measuring the, let's say, campus environment. We have basically local energy production and consumption, and basically we're developing towards a measurement framework for that. And we have plenty of tests for various different verticals. So if you go to the next slide. So this is the rough outline of our 5G test network. So we have a number of cores. We have Nokia standalone and non-standalone core. We have Open 5GS. We have Kumu core and Open EPC. As cores, as I said, we have 2 different macro stations and a number of rather large number of indoor base stations. We are federated to the Slices SC. We have a number of solutions inside a university campus with access to the Finnish university fiber backbone through a firewall. We have edge computing possibilities in basically in a different continuum. In addition to, we do RF research, so we are dealing especially with this 60XR with 140 gigahertz sub-terahertz transceivers. We have millimeter wave technology and a number of different smart devices ranging from unmanned aerial systems to AR and VR glasses to mobile phones, modems, etc. Next slide, please. Okay, with regards to the frequency licenses, we have quite a few of them, and basically, here you can see the numbers of our various different infrastructure. One thing to note is that when we are doing testing, we have professional measurement systems. So we're using Keysight Nemo for the RF interface monitoring, and for the cellular network or network monitoring, we are using the Cosium system. Next slide, please. And now we go to the VTT 5G test network.
Okay. Hi, my name is Jarno Pinola. I'm from VTT Oulu. I will be giving a short overview of the other research infrastructure in the North Node. So VTT 5G test network. We have the VTT campus in Oulu next to the Oulu University campus, and let's say the basic setup of the network is quite similar to the one that Jussi already overviewed for the university. So we have 5G standalone options for the access part. We have 4G connectivity as well, Wi-Fi connectivity and so on. Multiple frequency band ranging from 450 megahertz to millimeter waves, and indoor and outdoor coverage for the VTT campus area. A combination of open source solutions and commercial equipment or solutions can be used based on the needs of the experiments that are proposed. And we have, in addition to commercial UEs and SDR based UEs, also emulated UEs available for scalability testing at the VTT side. So we can generate traffic into the cells using the emulated UEs. Edge cloud and MEC processing capabilities with support to AI workloads, and we have an initial implementation of the energy monitoring or measurement framework also in place. So that is something that we are hoping to provide as an enabler to the OpenCall 2 projects as well. Next slide, please. A similar set of frequencies as mentioned, we are operating in the same area as the university test network. So mostly we have similar test frequencies available. For the user equipment, and especially for the emulations, let's say that for the commercial smartphone CPEs, we can support up to 10, a little bit over 10 simultaneous users using the physical user terminals. With the emulated UEs, we can go up to several hundreds or 1,000 simultaneous users, depending a bit on the type of the UEs that we need to emulate. So there is scalability there for the UE sides. And as mentioned, for the AI workloads, we have edge platforms equipped with the NVIDIA H100 GPUs available for the experiments as well. So I think those are the main enablers in addition to the basic baseline network infrastructure that we can provide. But more on those in the topics later on. Next slide, please, and I think we can go to the South Node.
Yes, hello everybody. My name is Aurora Ramos. I work for Capgemini in Spain. So let's see the overall South Node as a whole. That is composed by 2 research infrastructure. One in Barcelona, 5G Barcelona, that is led by I2CAT, and the partners, the 6GXR partners involved in Phitonic research infrastructure are Telefónica, Phitonic that is providing the 5G core and RAN solution, and Capgemini that we provide as computing infrastructure and make orchestration. So in the context of the project, we are working in connecting and federating these infrastructures. And a bit, next slide, please. A bit more on the details on how these connectivities perform is represented in this figure. So we have the 2 edge locations that are connected with an internet network. We have pre-configured slices that can be selected by the experimenters bringing in. We have capabilities for network as a service exposure with friendly APIs towards the application layer. We have run at both nodes. It was not represented in the previous figures because that was a simplification for the main focus of what we are doing in 6GSR, but indeed we have run infrastructure at both nodes, of course, and core network are at Phitonic. The 5G functions are connected through inter-site network, and at the transport physical level, the sites will be connected with RAID-FIDIS. Next slide, please. Okay, focusing on these network as a service capabilities that I was mentioning, because they are especially relevant for this OpenCall 2. It is representing here the APIs that we offer towards the application that, to mention, that are aligned with Camara Linux Foundation projects. And what they do is to hide, let's say, network complexities towards the application developer in relation to quality of demand, quality of service management, also for the allocation of the best edge resources in one site, in one research infrastructure or the other. And at the same time, it's integrated with the 5G core provided by Ericsson, as said before. So regarding the specific frequencies and these technical, let's say, numbers and the frequencies available and so on, you can check those are detailed in the OpenCall document. Okay, so I have not included here. And I think with this, we are done with the South Node. Thank you.
Yes, thank you very much. So this was a presentation of the four infrastructures that we are providing and we are offering, and you can have some details also in the info document. But if you have some more questions, please use the Q&A session that we have here, and also our email that it is in the presentation, but also in the website. So the next slides are a bit of more details on the individual topics that we have defined and referred just at the beginning, our coordinator, but also they are analyzed in the information document. So I'll give the floor to my colleagues here to give some more details topic by topic. And we start with the first topic. Can someone from Oulu, please?
So Marko Leinonen is on the line, and I see him as a attendee. So if you can enable speaker, he has his hand raised.
I think that he has to use the invitation that it was sent, but let me go back to the topic, to the second topic, then we'll come back to the topic one until we solve that. Let me go to the next one. So
Yes.
here for the 2.1, the same.
Okay, yes, it is from my side. My name is Kenichi Komatsu of this use case leader of this 6XR 3D digital twin use case. Then we are Northnode is working on the implementation and verification for this 3D digital twin with wireless deterministic communications. Then this one topic is verification of IEEE standard of time-sensitive network TSN, deterministic communication performance in the content of under the 3GPP standard of 5G mobile private network at University of Oulu campus. Then the gaps and goals for the target on this in the cyber physical world of metaverse type of world is need to verify the collaboration, the task between the real physical status like motion or location or more sensoring from the real world and digital contents of virtual reality 3D models in the VR glasses in the metaverse of those by the motion or location or positioning or there are other digital traffic, meaning like the video streaming or even voice or everything of the digital traffic. For this wireless deterministic communication capabilities, like minimum jitter or traffic shaping of those are the required in 3D digital twin applications. For example, like the mission critical type of XR interactions of the machine motion control signals are if mission critical type of topic, then have to be prioritized in the traffic than other than the other traffic like video streaming, if not important, just lower priority, but the machine motion traffic should be prioritized by TSN of those. Then University of Oulu 5G test network can provide, like it is already explained before, the 5G private local network. And then also we have some TSN equipment like control industrial switch, TSN switches, then XR devices like Quest Pro, Apple Vision Pro with mobile edge computing capabilities. Then it can be used for controlling and surveillance for the industrial class arm robot of university robot, for example, UR3 type of robot. But the equipments are not like limited of those. Like if, I mean, can supply and then can collaborate, that is also very much welcome for this topic. Yes, so this is the explanation or also requirement from my side. Then maybe this is from Mario.
Yeah. Hello everyone, my name is Mario Montagut from I2CAT, and this new subtopic is also about deterministic networking. Yeah, we all know that deterministic networking standards in the wired network domains have already emerged and have even been standardized. And these include, for example, time-sensitive networking or deterministic networking. The 5G ecosystem is already integrating these advances, but the full potential is not yet fully exploited, especially in the wireless domain. So the goal of this potential topic is to exploit the full potential of time-sensitive networking and deterministic networking in hybrid wireless and wired domains. Okay. So potential features to accommodate include 6G features for deterministic and predictable wireless transmission or wireless-friendly enhancements for TSN and deterministic networking. And the goals could be, for example, to minimize latency or to optimize the communication paths. But we're also very interested in 6G time synchronization solutions that can allow us to provide global time awareness over the end-to-end paths. And this includes the network domain, but also the cloud continuum infrastructure, and also the UEs, of course, and to incorporate hybrid, wired, and wireless enablers to guarantee deterministic networking over heterogeneous environments. So that would be pretty much the description of this subtopic. Thank you.
Okay, for the 3.1, our colleagues from Oulu.
Yeah, hey, my name is Hamid, and I am actually part of the 5G test network, and I will present this topic 3.1, sustainability enablers for energy measurement and optimization solutions. So at the University of Oulu side, we are not only focusing on the commercial side of the GNB side and the core. So instead, we are also focusing towards open source environments for 5G and advanced 5G test network. So here we have, in this context, the idea is that we want to explore these energy consumption with different Open RAN configurations and energy saving in open source environments. So the methods to explore these energy potentials using dynamic adjustment to the OAI RAN configurations. And the main idea is to do such configurations in a dynamic manner, so without restarting the base stations. And the experiment will involve these external meters. So at the University of Oulu side, we have many variety of external meters with this energy measurement framework within this open source 5G environment. And so the idea is to have real-time energy monitoring, and a server is placed for data exchange between the external meters and the different components of the open source environment. And so the proposed methods should provide real near-time adjustment to the network parameter optimization, and especially in a dynamic manner, so without restarting the base station. That way we will have much more, let's say, potential for energy saving in Open RAN configuration. And and after these network parameters, we have the idea is to use those data sets and training models for AI and ML algorithms, and then evaluate energy saving measures for network management and involving these dynamic configuration changes to have to find out these potential energy saving measures. So University of Oulu will, in the topic 3.1, will have the following topics for specific enablers. One, we have this evaluation of various configurations on OAI RAN and open source Open 5G core network components, measured especially with external power meters and baseline. So we have this baseline base station configurations, and then we compare these with the potential energy saving methods and depending on the RAN configurations. And second topic is the OAI RAN components that can dynamically adjust the RAN configurations. Those RAN configurations are listed here, such as bandwidth, TDD slots, MCS, and MIMO selection technique. So these RAN configurations should be based on APIs which are already provided by University of Oulu, such as energy weather forecast, energy pricing linked with the energy taken from the grid and the CO2 emissions. So these are the two main topics regarding the sustainability enablers for energy management and optimization solution.
Thank you very much. And for the topic 3.2, please.
Okay, I will describe the key topic 3.2. So under the same let's say umbrella title, on top of the VTT 5GTN, we are seeking solutions more on the estimation or new ways to measure the energy consumption of the network components in the network setup that is mainly running commercial hardware at the moment. We are offering the energy consumption measurement data that we have already collected from the setup for quite some time, and we have the measurement setup up and running in the production network as we speak, so that information can be and data can be used as a reference when assessing the new estimation or measurement solutions that can be experimented with in this topic. We are not seeking such a dynamic optimization for the commercial hardware that was described by Hamid in the topic 3.1, but the time granularity should be high enough to enable meaningful optimization of the end-to-end research usage in the test network, so including the whole path from the user equipment to the access network and to the core network and application server side. The other side of the topic is also the how to proposals on how to utilize the energy consumption data that we are collecting for different network management approaches. So taking into consideration the energy efficiency as a network management target, for example, utilizing AI ML algorithms in the process. And the main enablers for this topic, as mentioned, are the 5G RAN and core network components, which are continuously measured with external power meters, and the data that is collected from the infrastructure with those devices is available for the experimenters, and then the local renewable energy sources that can be also put into the mix when optimizing not only the energy efficiency but let's say the utilization of renewable energy at the cell site. So these kind of enablers are there too that can be utilized for this topic. We can go to the next slide. I think it's then 3.2, and do we go for the south node or for the north node first? I can continue with this 3.2 north node topic. So a similar approach as I explained previously, but now focusing on virtual network functions, doing multimedia processing and streaming functionality or workloads. So in addition to the communication infrastructure, we want to adapt the application side as well as part of the overall energy consumption optimization during the runtime of the network. And for this, we have the same energy consumption measurement framework, monitoring also the server infrastructure that is running the edge servers and the application servers at the 5G TNVTT research infrastructure. For this topic, the aim is to utilize the energy measurements and the estimation of energy consumption for the different applications to adapt the encoding and transcoding functions for the multimedia applications used at the sites, and also new methods for detailed energy consumption estimation or measurement in the user devices or inside the application functionalities are something that we are interested in. So in addition to the let's say server level measurements that we have at the moment, this kind of a more granular estimations for the energy consumptions are of interest to us. And similar to the previous case, the enablers that we provide are the application servers and the platforms that the services can be deployed on and experimented with, as well as the existing power or energy consumption metering framework that can be utilized to collect the data during the experimentation. Okay, next slide, please.
Okay, concerning the South Node, this is Roberto Viola from Digital Media and Communication Department of VComTech. Concerning South Node, this is behind the same umbrella of the previous topic, but more focused to the South Node use cases concerning holographic communication. So what we have in South Node, we already have some encoding and streaming capability based on common streaming protocols such as WebRTC and Dash. In our use case, we aim also to research on adaptive rate control for video streaming. We have developing some solution based purely on network informations. And what we are seeking with this topic about monitoring energy consumption is enabling new metrics in order to improve this adaptation rate control, meaning that also energy information can be used for this video rate adaptation. So what we have in South Node is a lot of metric about the network, but we don't have any framework in order to measure how our VNF are consuming the energy. So a possible proposal for the applicants could be providing the South Node with some framework for monitoring the consumption of our multimedia function. This could be focused on GPU encoding process or streaming or whatever capability that are available through our VNF functions. Provided some visualization tool in order to see these metrics that are collecting from the VNF. Also, a possibility could be provide some optimization strategy that use both these metrics and the one related to the network that we can provide. And concerning the infrastructure or the VNF that we can provide, we have what we have in the South Node in 5G Barcelona it's a server capacity in order to host virtualized network function, both our network function and yours, some network function that you could provide. In the case of our network function, what we have from VComTech that can be deployed in the South Node is some VNF that are capable of using GPU in order to encoding and decoding content. For example, we have a remote render VNF together with a web player in order to show this content. This solution is enabled of using both WebRTC streaming and Dash. So this is quite related to the previous one, but this is more focused on the VNF that we already have deployed for streaming in the South Node. And
Okay, this is Jussi. I'm substituting for Antti Pauvonen, but before that, I would actually propose that we go back to topic 1 because Marko Leinonen is now on the line and can present it. So Marko, please go ahead.
Hello, can you hear me?
Yes.
Thank you very much. So my name is Marko and I come from the University of Oulu, and first topic here is the 150 GHz reflective intercell surface, and one of the reasons why there will be reflective surfaces to be implemented in the 6G system is that we will require new possibilities to reroute the radio signal at very high frequencies. And the high frequencies now means that the frequencies which are beyond the current 5G systems, which are now to be standardized up to 114 gigahertz. Now, what we are at the moment working as a disruptive 6G path here in 6G is that we are now developing new radio solutions for 150 gigahertz and 300 gigahertz. And two organizations are now working on the topic. So IMEC is working on 50 gigahertz and the University of Oulu is working at the 300 gigahertz systems. What we are now after is the 150 gigahertz reflective surface, which can be used for OTA testing and validations. What it means that we can provide a test environment for such kind of reflected surface to be measured or the air condition. At the moment, what we have at the University of Oulu, we have automated risk measurement system, which can be used for RF laboratory validation. And we have already done quite a few measurements with the system, and that's why we are confident the system itself is working as expected. For real communication signal, which is also one of the hot topic at the moment in the different domains, which kind of 6G system there will be, we can then also provide infrastructure that we can really use real developed 150 gigahertz radio transmitter and receiver for the communication purposes with the reflective surface done by a sub-project. So that's in a short. Thank you.
Okay, so continuing. So I'm substituting here for Antti Pauvonen, who is the mentor at the University of Oulu. So basically 5G slicing is an integral part of the development, and we are looking for solutions, especially artificial intelligence and machine learning solution algorithms that basically control the resources of a sliced 5G network in an efficient and dynamic way. So we're looking for both supervised and distributed deep reinforcement learning algorithms. So the primary focus, we are looking for solutions that basically target Kumu core, which is a 3GPP compliant 5G core itself, but we also have Open5Gs core available with the XApps to basically do this work. The target is to use commercial base stations with Kumu core, but on the other hand, our network infrastructure is flexible, so meaning that if, for example, Open5Gs is used, we can integrate them with the USRP radios to do a more local operation and testing. So what we expect from the proposers is that we're looking for run resource control as a part of a standalone sliced 5G network. The proposer is to actually propose what kind of parameters it is planning to adjust with this slicing. Also, to define the measurement, the data and the measurements, basically what needs to be done in the network. And the target is to actually have a fully integrated and tested AI or machine learning implementation for the 5G TN that basically operates on the parameters that we have agreed on the project. Oh, next slide.
Okay, this is Roberto from Vigontech again. In this topic 5, what we are seeking is solution for load balancing and service migration to enable the cloud continuum. What we have in the South Node are 2 edges that are federated and can run distributed application. From VConTech, we also provide media function enabled to process point cloud rendering, video encoding, and streaming. So the goals that we have in this new topic is to have some proposal that will enable us a more flexible deployment of the VNF on top of these two edges, also taking care about the end devices. Possible solution could be some load balancing or service migration capability, both intra-domain and inter-domain. In the case we consider also the UE, some task offloading framework in order to offload UE task to the edge. And what we can provide for this topic is, of course, server capacity at the south node, with our edge node that can host virtual network functions. And we also can provide some VNF that can be deployed either in Madrid or Barcelona. And for example, the remote renderer and the web players that are enabled with streaming capabilities. Okay, next slides.
Okay, my name is Amra Abdelnabi. I'm from I2CAT. Basically here we are targeting the mobile load balancing on ORAN compliant RAN. Here we have an XR user who is served by 1G node B, and then there are other users in the same cell served by the same G node B. They are creating other type of traffic rather than XR, so they are causing interference, and they are degrading the performance for the XR, while there is another cell close to an adjacent cell, which has less users and less traffic. So we need to move those users from this cell to another one, to the unloaded cell. So we are seeking to develop an algorithm that is responsible to switch those users from the congested cell to the uncongested cell or the unloaded cell, and utilize the E2 KPM and E2 RAN models to detect the congestion and track the utilization of the radio resources. Plus testing this on an ORAN compliant testbed. So this is basically what we are seeking here. Thank you.
Okay, so we start the block related with security and trust. The first topic is related to the south node, where, as anticipated before, we provide APIs on top of the edge infrastructure for MEC orchestration. So these new APIs aim to they make the access to network capability easier, let's say, for the vertical application, XR application in this case, providers, developers, so can control easier the quality of service that is provided to each application, the different resources that are allocated, and so on. Those APIs are aligned with Camara Linux Foundation project. So specifically in this topic, what we are looking is for technologies, mechanisms to improve the security and trust in this interaction. It does not mean we're looking to update the APIs, but to add on top a mechanism to improve the trust between the vertical provider, the application provider that will be deploying the application onto the telco infrastructure. So again, it's adding a mechanism on top to improve this trust and security, also privacy among these two levels, application and the telco infrastructure. So we can move to the next.
Okay, so again, from the point of view of the VTT test facility in the North Node, we are seeking in topic 2.6 adaptive confidential computing and security solutions that we can test as part of this end-to-end energy consumption optimization, let's say, concept that we are working on at VTT, the project, and especially the assessment of energy consumption for different security levels and configurations in the computing confidential computing environment is something that we are interested in. The proposers should provide or have solutions that can be deployed on top of the test facility here at VTT. So should be able to run it in a virtual machine or in a container environment on the test facility servers, and a set of test cases should be also defined in order to assess the adaptability and energy efficiency of the provided solutions. Again, we can utilize the existing measurement framework that we have in the test network to verify the effect of the configurations changes and different security levels on the energy consumption of the platform. And for this both the server capacity and the infrastructure monitoring enablers are available for the experimenters at the VTT test sites. That's it for the topic 6.2.
Okay, topic 7 is about increased capacity 6G channels. As we all know, the promise or the ultimate goal of next generation cellular technologies are to provide similar performance level to those that are achieved in wired networks in terms of different KPIs, data rates, latency, or reliability, while still providing intrinsic features or advantages of wireless networks, like mobility. So you are not connected to a cable, or sensing. Also, we could use accurate localization and sensing. So the goal of this topic is to accommodate potential new enablers and ideally standards compliant enablers that could contribute to this mission, we could say. It's quite a broad topic. And potential enablers could include, for example, a strategic usage or aggregation of parallel transmission channels. For example, if we have Wi-Fi and 5G channels, we could split, or we could do different strategies to increase the capacity of the media transmission. We could also accommodate radio channels that are using spectrally efficient or robust bands, or new modulation schemes, or any kind of signal processing technique to increase the capacity. Intelligent mesh networking protocols for private networks could also be within a scope, or accurate integrated sensing and communication capabilities, ISAC. Yeah, probably if you are hearing or listening to this webinar, or you're reading the topic, you have the feeling that it's quite a broad topic. Yeah, we are aware of this, and this could encompass both potential enablers that could be integrated within the South Node, or maybe also the North Node capability, but we are also open to accommodate a standalone proof of concept that are compared against baselines. So that would be the description of this topic in a nutshell. Thank you.
Okay, and then finally, as this is an open call, we also need to cater for, let's say, other study beat thematics that we have not covered or identified. So this topic is for other topics that do not fit, especially in the ones above or addressed before. So, I mean, there are no specific goals and objectives, of course, for this topic, because it's basically a free proposal to the proposers. and it actually puts a bit more burden for the proposer. So obviously the proposer, with the help of 60XR, need to define the node, the research infrastructure, and the mentor for this particular call. So I encourage everybody thinking of a thematics or topic in here to contact Open Calls 60XR@EU for consulting, making, let's say, an initial proposal. We can identify the node, the research infrastructure, and the mentor. So the feasibility check is mandatory with the deadline of 22nd of April, and as stated before, we will accept a maximum of 3 proposals under any topic, also this topic. So bear that in mind, that even though your proposal might be extremely good, basically if it falls under this topic, it has a higher likelihood of not being funded. So of course, the proposals are required to justify the linkage to StreamB thematices, and basically the same is that if the proposals are coming out as a result of a StreamB project, they are required to ensure that the work is novel and not already funded by the European Commission in respective grant agreements. So there also, so if it comes out of these StreamB actions, there needs to be a clear justification how the proposal goes beyond the project description of action, and basically what is the difference between the respective description, action, and this proposal. So that's it. I think we can go then to the questions and answers section.
Yes, thank you very much all for the presentation. We have one question in the Q&A session, but please feel free to raise your hand and ask any questions that you might have. So the question we have at the moment is only if the Open Call 1 participants are eligible to participate also in the Open Call 2. I would say yes, the participants, the applicants, yes, but only every beneficiary can be funded only once during the open call process of the project. Juicy, maybe you can have some more details on that.
So we have not defined any explicit other details on that, so that stands.
Yeah. But this is the general rule. I mean, only each beneficiary can be funded only once per the project, no matter how many open calls we are running in the project, but you can apply as many times as you want, unless say you've been funded in the previous open call. Now, any other question? Yes, please. I see a raised hand.
Yeah, hi. I would like to know that is it possible to get the more information about specific projects that already explained here? For example, I would like to get more information about the trust mechanisms upgrade.
So I would recommend to write an email to basically opencalls@60xr.eu, specifying basically what are you looking for, and we'll try to forward that to the potential mentor for response.
Okay, thank you.
Any other question, please? Okay, so thank you very much for your participation. The presentation, but also the recorded webinar, it will be uploaded in the project website under the Open Call 2 webpage, so you can run through the entire video and documentation and slides, and you can come back to us for any other information you might need in order to put together your proposal and submit it for the visibility check up to the 22nd of April in the emails that are mentioned here in the slides. I don't know if from my colleagues, from the presenters here, do you have any additional information that you would like to give or any comment to make? Jussi, maybe you want to close the session?
Okay, so thank you for all of you attending the session. So this session has been recorded and will be basically put onto the website for later review. And of course, if you have any questions, please contact the open calls at 60xr.eu. This is the only official communication channel for regarding open calls, and all interactions should use this because we are also obliged to collect statistics about interaction. We have to also be able to provide proof of all interactions if necessary. So thank you, everybody, and have a nice rest of the week.
Thank you. Bye bye.